Hello, right, I thought this would be instructive to show everything of all the pieces of the 15.6-inch Libre hardware laptop before they end up actually being assembled. This is the casework. This is a GPL open hardware Python OpenSCAD files which have been used on a Mendel 90 RepRap printer, RepRap style printer to 3D print all these pieces. These parts are available now because this is a Libre project, not a will promise to give you the parts and all the files once they are all done. These are available right now and always have been. The screen fits into that area there. The blank areas that you can see will be filled with bamboo panels because it's an eco laptop. Why would you want to print extra pieces of plastic when you can fill it with renewable materials instead? Just as good. This is the keyboard controller, which goes in this area here in an L shape under there, so the keyboard goes in that part there. This is a SPI and I2C based 3.5-inch LCD with a capacitive touch panel as a single unit. This part, I haven't been able to get on with it to get the SPI based screen to work, so I found an alternative supplier. Hello. I found an alternative supplier which has a much easier connector to work with apart from anything. I have, however, managed to get the I2C touch panel working. There is another video which I showed how the keyboard is actually working as a USB HID device and as a CDC ACM USB serial. So this at the moment is connecting to a laptop for the thing, so you can program the boot firmware on that. Instead, what that will go into is this one, and there is a USB port here. There is a 10-pin header here, which goes into the 10-pin header here on this board. Then this one goes to the power board, which has an 8-pin header here, and then the power from here goes to the 6-pin header on this one. So all three boards have had to be connected together. Now this is the main laptop board. We're calling it PCB1. I have a USB UART here for when plugging in the CPU cards, which is this. These are the credit card sized things. This is a revision 1.0, which I don't know if you can see. I've had to put on some wires. There we go, some wires here. Because I blew up all 4 of the revision 2.2 CPU cards when shorting out the 3.3 volt to 5.5 volt rail here. It damaged all of the GPIO pins and the USB ports of that board, so I had to use the older CPU card. Here's the battery. This is an electric bicycle battery. It's $10 in volume, possibly even less. Given that most of these 10 amp hour batteries are specifically for laptops are $25, that is a huge saving when it's absolutely fantastic. This is the power board. There is Linear Tech LTC4155, which I do not recommend for any purpose. This chip is not fit for purpose, and the Linear Tech support staff were extremely unhelpful in dealing with the misdirection on their data sheet. So that will be replaced with a Texas Instruments BQ24162, I think it is. which is fit for purpose and is properly compliant with the USB on-the-go power specification. This chip is not. It will be sufficient for the demonstration purposes of the prototype, however. Also included on here is an STC 3155, which is a Coulomb and voltage charge. It's a battery monitoring thing, so you could IC, so you can check the status, monitor the status of battery properly, and report how much charge there is remaining in it to the user, which goes via I2C monitoring, which will be carried out by this baby under here, which is an STM32 F072, which over that serial cable, which will be hardwired into here, will go through here onto this CPU card, and the CPU, which is well, on this one it's an Allwinner A20. However, that's the whole point of this, is that it's an eco-conscious laptop. You are able to upgrade this. I have the Ingenic JZ4775 boards arriving on the 4th of January. Way! Those will be FSF endorsable, so the whole laptop will be both Libre hardware. You'll be able to replace the casework parts yourself. These boards, where are you? This one, that one, and this one will be available. The CAD files will be available for those, so you'll be able to manufacture your own replacement PCBs under the thing. The only thing requirements are that you will need to comply with the GPL and make the modifications available to other people. This is one of the first micro desktop boards which has been used to both power this board, and also this is another project which is going on crowdfunding. I'm on to revision 3 of this board at the moment, and you can see there's I've got again a USB UART, just like I have for this one. There's another USB UART. So it's been extremely useful in debugging these boards and powering stuff. There's a 3.3 volt power regulator on here, which I've been using to power the battery monitor, the ST battery monitor chip, etc., etc. Using this board whilst it's been debugged has been painful, so it was actually better to use that one. Because there's a USB hub chip on this, which I wasn't sure if it was working, etc., etc. Turns out it wasn't. I messed up the order of these, so I've had to wire this upside down, etc. By the way, yes, the last piece in the puzzle which I described earlier was that needed to be checked was the audio. So this is a simple C-Media CM108AH. It's like a 80 cents chip, $80 US chip, and sorry, 0.8 US dollars chip. Then you have 2 TDA 2822s, which are 1 watt each. So you've got 1 watt things, and then of course I plugged it into 2 half-watt speakers. Okay, which just can't cope. It's what I have. Headphone socket. And a condenser microphone. It does the job. It demonstrates that the circuits, the audio circuits, which have got here some 100 microfarad capacitors, etc., etc., all work. Micro SD. So this board is all fully working. Yay! So at this point I can do the assembly. That's the Texas Instruments SN75 LVDS83B. This is the 40 pin connector which goes to the LCD. So we have everything working. I can start assembling. It's going to be a lot of wires, a lot of fun. So what I will do first of all is I will just assemble all of this. Oh, this is just one thing, more thing. This is that's a 68 pin connector which can go into there or there. I've wired up a USB cable onto it It's the equivalent of a pass-through card without the actual circuit board, and it's been very useful already, because what I was able to do was to plug that into here and then that into the laptop, and these wires were the equivalent of bring up on the power circuits here, which enabled the 3.3 volt circuit, and the GR850G came up, then the CMA108AH, and I was able to test on here the USB audio circuits as being functional, and then was able to plug that CPU card in next once I'd proven that had all worked on there. So I'll do that as a demonstration video next. So yeah, I've got all these pieces, so that, and that, minus this, will all be going into there.